All right, so it's the lesson, and it's actually the first part from section 5.3 in the textbook. It's actually a very short lesson. Just focus on how you can describe an interval in a few different ways. So the lesson's quite short, the homework from this section is quite short, and it leads into the next part of the same section, which we talk about domain and range, which is a bit more involved. So first, an interval. An interval is sort of a set of numbers. And an interval can be described in words, visually, or on a number line in either set notation or interval notation. And these two things that are in bold are what we'll talk about the most here. If the values are discrete, which means you're literally having a list of whole numbers, for example. If values are discrete, then your interval can be written as a list. However, if the values on your interval are continuous, it's not possible to write them as a list. And we'll see some examples. So let's look at this first interval. For each of these, I want to show it on the number line. And first I'm describing intervals in words, and then these other ways, which I'll get to. All right. And so the first statement says all the real numbers less than 3. So real numbers are just numbers that are real as opposed to fake. I mean, there actually are things called imaginary numbers that are not real, and we don't talk about them in high school. So essentially, every time you see the phrase real numbers, you can just think all numbers, anything, any number you can think of, fractions, decimals, whole numbers, and negatives, anything. So all the real numbers less than 3 means all the numbers that exist that are less than 3 but not actually equal to 3. So how do you show that on the number line? Well, let's look at 3, and I'm going to put a circle around the number line there, an open circle. And then I want to color in my number line to the left of it, everything less than 3. And since it says all the numbers less than 3 and that's it, well, there's no limit to how far down I can go here. So I'm also going to draw a big arrow. And again, I have an open circle right here at 3. And that there is a visual on a number line of what all real numbers less than 3 means. It means everything you see shaded in, everything less than 3, but not quite including 3. All right? I will, though, as well express this interval in a few other ways. Okay? If I want to express this interval in set notation is what I have kind of right here for this question down here, that part I've highlighted in yellow. If I want to express this in set notation, all the real numbers less than 3, then for this I would just pick a variable. I'll be boring and say x, and I can just say x is less than 3. There we go. That statement there, the number line I've drawn, and the words all mean the exact same thing. X is less than 3. All right? Another way of expressing this, which is probably new, is called interval notation. Interval notation is like these last examples down here. Okay, that's probably quite new. So the way I can show this in interval notation, all the numbers less than 3, and this will probably seem kind of weird at first, is all the numbers less than 3 mean everything from negative infinity up to 3, not including 3. So the way I can show this is I put a round bracket, negative infinity, comma, 3, and another round bracket. So what this means is a round bracket means, well, first, whatever value we see on the left, that is a smaller value. And now negative infinity is not a number, but you can't get smaller than negative infinity. And so that goes first. 3 is the biggest value in this interval. And round brackets, as opposed to square brackets, mean you don't actually quite reach that number. So like I said, it's less than 3 but not equal to 3. And so it's a round bracket. If I put a square bracket right here, then this would be up to 3 and including 3. And again, we'll see examples of all of these things. Okay? So I've done a little more than I have to. All I really have to do for this first one was draw the number line. But next, all the integers. So integers are whole numbers, but they may be negative. So how do I show that on a number line? Let's pick a color. Green. And 0 is an integer, 1's an integer, 2's an integer. And I'm quite simply going to draw a filled-in circle for every single integer. Now, I guess I guess I don't really have to do every single one, but I will. And so on a number line, all the integers looks like this. It's discrete. The points between, for example, right here, a half. A half is a number, it's a real number. It's not an integer. And so all the integers looks like this. And so that's what all the integers looks like. I can't really show this statement, all the integers, I can't really show it easily with these methods because it's not continuous. This is a discrete set of points. And again, so I'll just leave it like that. There is a way I can show it using this method. It's a bit messy. It's not possible to show it using this method. Okay? And remember, all I asked for each of these questions was to show these values on the number line. All right, so next. How do you even say this? Well, the part I've highlighted is all that really matters. All right? What this means here is, first, this x tells us that's the variable we're going to use. But then we see it here again. So x is the variable we're using, but all that really matters is what I've highlighted in yellow. So the way you read it is -2 is less than or equal to x, which is less than or equal to 2. And then this next little statement right here means that x can be any real number. That's what that symbol means. X can be any real number between -2 and 2, including that. Which just means when I'm talking about all the numbers from -2 to 2, I'm including all the fractions and decimals in between, not just whole values. All right? In the end, though, all we really need is what I've highlighted. And so when you're looking at similar questions in the textbook, I would encourage you just to focus on that sort of part, not to worry about the rest of it. At a grade 10 level, I think it gets a little bit too messy. So what does this mean? -2 is less than or equal to x, which is less than or equal to +2. Well, in the number line, let's pick this color. I'm going to find -2. And I want to color that in with a filled in circle. And I want to fill in everything on my number line all the way up to +2. And there we go. That there visualizes on a number line all the values from -2 up to 2. If this right here didn't say all real numbers, if it said all the integers, sometimes it's shown as an I, then this would be a series of dots. -2, -1, 0, 1. But that's not what it said. And so in the end, that's what that phrase means. That -2 is less than or equal to x is less than or equal to 2 really just means all the numbers between -2 and 2, including -2 and 2. All right, I can show this one in that interval notation quite nicely. Interval notation, again, being kind of what I have here. In interval notation, I would use square brackets because I want to include -2 and 2. So I'd write square bracket, -2, comma +2, another square bracket. And so interval notation is another way of showing an interval. And again, what you see here, all highlighted in yellow, is equivalent. I like this the best, but I don't really care. They're all the same thing. Chances are this is new to you, and maybe this as well. But they all mean the same thing. Okay, and the purpose of this short lesson is to get familiar with all of these. And it makes sense that some you're going to be more familiar with than others. All right, so next one. X, where we have x is less than or 0 and x belongs to all the real numbers. All that matters really is that. And the way we read that is x is less than 0. So what does that look like on a number line? Well, I find 0 and I put an open circle around it because it says x is less than 0, not less than or equal to. And then I just fill in everything to the left because everything I'm filling in to the left of 0 are numbers less than 0. And again, it goes on forever, so put the arrow there. And now that's what that means. All right? If this was a little different, if there was a bar right there, then that would mean x is less than or equal to 0. And then the difference would be I would also fill in. The number 0 would be included. But that's not how it is. So let's get rid of that. OK? So that's how you show that in set notation. And again, I want to do a little bit extra. I want to show this in interval notation. So this means all the numbers from -infinity up to 0, not including -infinity, because you can't actually reach infinity, and not including 0. So this would be a round bracket, the -infinity symbol, comma, 0, and another round bracket. And again, if the question had that little bar there, if it was less than or equal to 0, then this would change slightly to have a square bracket right here. The square brackets mean included. But again, let me go back to how the question actually was, which was like that. Last two, and these are already in interval notation. And so what does this mean? Round bracket, -infinity to comma 0, round bracket. Well, now we can see what it means. It's what we just had right above it. This means the same thing. So I can just draw the exact same thing. Open circle at 0, shade it in to the left. All right? So again, this, and this are all the same thing. Okay, they all mean the same thing. All, effectively, all the negative numbers. That's what that really is. In words, I could say all negative numbers. Because 0, if we're not including 0, this is all the negative numbers. And so lastly, negative infinity to positive infinity with round brackets. What does that mean? That means absolutely everything. It means all of this, the entire number line. It means everything. It means all numbers. It means all real numbers. So another way of saying this is we can literally use the words all real numbers. That's what that means. That means every single number that exists. And another way of writing that is actually what we kind of saw right there. That, what I've just highlighted in pink, means all the real numbers. Now, this one right here had an extra constraint where x had to be less than 0. But if all I write right here is x, this is, we say belongs to, and a capital R, that here means the exact same thing as this phrase. It means the exact same thing as this in interval notation. It means this as a number line. This here means just this by itself. Means all, x can be any number you want. There's no restrictions. And so the number line covers everything. And so to remind you of the terminology here, if I clean this up a little bit, because yeah, this has gotten a bit messy. I have a knack for that. So if I just go back to what I had here, like I said, there's many ways of expressing an interval. These first two are in words. I'm expressing an interval in words. These two are in set notation. And these last two are what we call interval notation. All right, chances are some of these right now seem easier to understand than others. Probably the number line is the easiest to visualize. That's what number lines are good at. But they're also kind of the most annoying to draw sometimes. In the end, you just need to understand how they're all connected. And you want to be familiar with how to read all these things. Common mistakes are misreading these symbols here. Remember, that's less than. It kind of looks like an L. That's greater than. That's less than or equal to. That's greater than or equal to. And students tend to mix these up a lot. All right? So again, with that said, the homework from this is very, very short. It's just the beginning from this one section. Once we know how to read and write with this interval notation and set notation, then I can start talking about domain and range a little bit better. And that is it.